We're going to be looking at some limits for trig functions. So let's point out two very important pieces of information. The first one is that the limit as x approaches 0 of the sine of x over x equals 1. You can also state that the limit as x approaches 0 of x divided by the sine of x also equals 1. Alright? The second case is that the limit as x approaches 0 of 1 minus cosine of x divided by x equals 0. Now we're not going to prove these, but you're welcome to ask your teacher for help. There's a really good explanation for this, but for now we just really need you to accept them. So we're going to use these and basically substitute. That's what we're going to use them for, some substitution to figure out some more complicated limits for trig functions. So let's look at a couple examples. The first one states the limit as theta approaches 0 of sine of 8 theta over theta. What does that equal? Well, what we should first do is use direct substitution. If that doesn't work, if it yields an indeterminate form, meaning you're probably dividing by 0, then we're going to refer to one of the cases above. So if we plug in 0 here, well, we're automatically going to be dividing by 0 in example 2 there. So that's going to yield an indeterminate form. So we're going to look at one of the special cases up at the top. Well, this is a sine. This involves sine. So that's probably going to be the first special case. Well, let's see here. I have the sine of 8 theta divided by theta. What would make the difference? Well, that 8 there is making a difference because otherwise I'd have sine of theta over theta, and that would just equal 1. Well, we're going to multiply by a factor of 1 to change this. So let's go ahead and look. Let's see here. The limit as theta approaches 0. And what we're going to do is multiply by a factor of 1. So I'm going to multiply by 8 over 8. So I'm going to write 8 sine of 8 theta over 8 theta. Well, I want you to make note of something right now. If we were to cross this out, and instead of saying 8 theta, call this x, and in the denominator, call that 8 theta x, well, notice what happens here. We basically have sine of x over x. And we know from this special case that the sine of x over x, the limit as theta approaches 0 of the sine of x over x, simply equals 1. So I'm going to state that this right here is just 1. Now you might recall from a previous theorem that the limit of a constant is simply a constant. Well, 8 times 1 is 8, and that's a constant. So I have then the limit as theta approaches 0 of 8. Well, once again, since it's a constant, it simply equals 8. So there's our answer there. Notice the substitution that was involved and the fact that we multiplied by a factor of 1 to manipulate this. Okay. Now let's go ahead and look at the next example. It says the limit as alpha approaches 0 of the tangent of alpha. Well, which special case should we use? We didn't mention anything about tangent. We just mentioned sine and cosine. Well, let's go ahead and look once more at the directions. In finding the limits of trig functions, use direct substitution first. Have we done that? No. Let's go ahead and try. So, the limit as alpha approaches 0 of the tangent of alpha. So, if alpha is approaching 0, then I'm going to write, well, tangent of 0. I had a really good pre-cal teacher, as I recall, and I learned something about a unit circle and various trig functions. And I know that the tangent of 0 is simply 0. You can probably verify that on your calculator. Well, you can verify it on your calculator. The tangent of 0 is 0. So in this case, direct substitution worked. So the answer for this one, the limit, is actually going to be 0. Now you can look at the graph of tangent and you can verify this on the graph of tangent that it actually does approach 0. Okay? So that's an important thing to note. So when you're working with limits of trig functions, you're probably going to have to refer to these special cases, or you're going to have to manipulate them in some way so that you can get them to appear like one of these special cases. Another tip for limits of trig functions is that you're probably going to have to incorporate the use of algebra, so probably the difference of two squares and some other factoring techniques as well. You're also going to need to recall all of those trig identities that you learned in pre-cal. So know that tangent is sine over cosine, cotangent is cosine over sine, and so forth and so on. Know how they're all related so that you're able to manipulate these trig functions. So this is just a brief overview of limits of trig functions and what you can do with the special cases.
Made with Doodlecast Pro.